Madam, we will start, madam. Madam.
Yes, Sarika. Okay, very good afternoon to one and all. And today we are having a resource person, Dr. N. Kamala. She is having total teaching experience of more than 30 years. At present, she is working as an associate professor in Jain, deemed to be University, Faculty of Engineering and Technology, Ramanagar District, Bangalore. Her current research interest includes artificial intelligence, machine learning, robotics, and automation. Today, she is going to be delivering on topic battery thermal management and safety regulations. So, I welcoming our resource person now. Now the session will be handed over to our resource person, and she'll be continuing it. Ma'am, please, ma'am. Ma'am.
Yes, ma'am. Thank you so much. Thank you for your kind words. Very good afternoon, all of you. First of all, I am very thankful for inviting me for this wonderful session, which is the need for the hour. So, I am made the host now, right, ma'am? So I can share my screen now.
You are the host now. You are the host.
Okay. Can you see the screen?
Yeah, it's loading, ma'am. Yeah, we can see, ma'am.
Okay, fine.
Yeah.
Yeah, it's loading for me. Okay. Thank you so much. So now we can start our topic on battery thermal management system. In the previous sessions, you would have learnt enough of a battery management system. You would have had a very good insight into what is the electric vehicle and what is the need for the electric vehicle, what is the need for the battery, what is the need for battery management system. So now what is the need for the electric vehicle? Basically, we know that why electric vehicle came into existence is because of the depletion of fossil fuels, and also to improve the air quality, and also to reduce the noise pollution, air pollution, and to preserve whatever is the resources are there. So for that only we have come across the electric vehicle and the various parts of the electrical vehicle, that is various components of the electric vehicle. We can see the major components are nothing but it is having an electric motor, that is a drive, that is used as a drive. Electric motor is there. Then electron control module is there, traction battery, battery management system, a smart battery charger, a cabling system, regenerative braking system, vehicle body, frame, EV fluid for cooling, braking, and also the lubricants. These are the various components that are used for the electric vehicle. And also, we'll have a small glimpse about what are the components that are being used. I said the drive system is nothing but the electric motor. So it is propelled by electric motor. It is in turn controlled by the engine controller or the electronic control module, that is the ECM. So it is we can have, previously we were having DC supply for that, but because of the advancements in the power electronic circuitry, then we can have AC now. AC is being utilized now. And also there are battery packs, and what are the different batteries that we have used. So the battery cell has major components like electrodes, anode, cathode, separator, terminal, electrolyte, and a case of the enclosure. So basically the batteries are nothing but it is the heart of the electric vehicle. So the electric vehicle's performance, cost, safety, or the reliability depends upon the battery performance. And also we know that the electric vehicle is very costly, and 1/3 of the cost of the electric vehicle is being contributed by the battery itself. And also 45% of the electric vehicle cost is only the battery related cost. And because battery plays a major role in electric vehicle, there are so many researches going on the battery performance and the chemical component of the battery to increase the performance, longevity, reliability and the safety of the battery. Because with the degradation of the chemical component in the battery, the performance of the electric vehicle will go down. So we know that the chemicals in the batteries degrade over time. So if it is a degrading over time, the performance of the vehicle also comes down because of the performance of the battery. And also, what is the battery management system, which is needed for enhancing the battery performance? Battery management system is to get data from the battery, estimate the state, equalize the charge, then thermally manage the battery cells. Why we have to manage the thermal problem here, thermal issues here, that we are going to see in this lecture. And also cycle life and performance of the battery while reducing the associated cost. So here we know what is the battery, what is the working principle of a battery, because basically a battery consists of anode and a cathode, and there is an electrolytic medium in between that anode and the cathode. And when an external circuitry is connected to this battery, then what happens? There is flow of electric current. It is basically because of the transfer of electric charges between the anode and the cathode. Actually, the current flows from the higher potential to the lower potential, because of which the current flow is happening. Okay, so this is what is the battery we have seen, and there are different types of batteries. That is a lead acid battery, nickel cadmium battery, nickel metal hydride battery, lithium ion battery. So many batteries have they have tried with so many batteries, and they have arrived at which is the better, which is giving better performance. So in that way, we are coming across the lithium ion battery, where the electric conductivity is happening because of the ion exchange here also in the lithium ion battery. So here, lithium ion battery, how it is looking like. So what is the major components of the lithium ion battery, and what are the various configurations of the lithium ion cell we are going to see. Either it can be cylindrical or it can be prismatic. So if it is cylindrical, there are two types of cylindrical configuration. One is the jelly roll and another is can. And prismatic is either it can be wound or stacked layers or soft pouch. Here you can see that anode cathode will be there. Okay, so the electrodes will be there, which are separated with the separators. Okay, so here the separators will be provided, and you can see it very clearly here. The battery cell configuration is shown here. So there will be a positive electrode, negative electrode, and also the separators are provided between the electrodes. And also there is a positive terminal, negative terminal provided to the battery, from the battery. And this is enclosed within the case, because we know that the battery cell has to be cooled. Because why it is getting heated? Because when we are charging, when it is carrying current for a longer period of time, obviously the heating occurs. So it has to be cooled for protecting the battery. Okay. So here I have shown the different configurations. If it is a cylindrical configuration, the arrangement of the cells, that is the anode, cathode, and as well as the separators are provided like this. So its cross section appears to be like this. And if it is prismatic, then it is like a book. Okay, so here it is provided with a positive electrode, negative electrode, and also separators are provided. This used in the Nissan Leaf lithium ion battery cell. And if it is a pouch type, so you can see this is a pouch type, which is used by Cadex Electronics in Perfect. So here we have seen the different configurations of the lithium ion battery and how it is being placed in a vehicle. That is what is shown here. So basically the battery is provided the case and also the cooling arrangement. And you can see here it is showing the setup of the lithium ion battery cells here. So here the various cells are there. Okay, so here the battery management system is there. I'll explain you what are the different components of the battery management system. And also here this voltage management is there. Actually here when we talk about the battery management or the electric vehicle management, here there are two types of management we have to see. One is electric vehicle management, that is electrical management should be there. Next, battery management should be there. Okay, so here that is to the accessories we are giving the electricity here. So here the various cells are provided, and here the thermal management is there. Here the battery management is there. Here the thermal management is there, which is going to circulate coolant across this. So now with a single cell going for a pack of cells, which is going to make a module. Okay, so that is going for a pack. Okay, so that is the many cells. Here 69 cells. So for a Tesla roadster it is given 69 cells per brick is making a module, and 11 modules is going to make a pack, and which is incorporated in the vehicle. So for Tesla roadster and as well as Nissan Leaf is given here. It is a Panasonic cylindrical cell is given here for Tesla roadster. And AET, that is Automotive Energy Supply Corporation, which is which made this cell. Okay, so using that, they have employed that in the Nissan Leaf. This is also like a lithium-ion battery cell module. So first cell is there, which is combined to make a module. Modules are combined to make the pack, and then it is placed in the vehicle. So now coming to the battery management system, because we know that battery is the heart of the electric vehicle, and also we know that 1/3 cost of the electric vehicle is contributed by the battery, and also 45% of the cost is because of the battery and its associated components. So our main focus should be on the battery management system. So why we have to manage the battery? What is happening with the battery? Because we said battery is made up of a chemical composition with respect to the time. That is, the degradation of the chemical component is taking place. Because of that, the performance of the battery goes down, and with the performance of the battery, the performance of the electric vehicle also goes down. So there is a need for the battery management system. So as I said already, it is the electric and thermal management. So electric management and as well as the thermal management has to be done for the batteries. So here, what happens with this is, so the capacity and the voltage of the battery cells. Normally, the capacity of the battery cells will be very less. So here, so we have to go for many units of the battery which are connected in series. So they have to be connected in series to satisfy the high voltage requirement of the EVs. And what happens because of connecting many batteries in series is that because of the manufacturing inconsistency and also the operational variation, there is one thing called the SOC, that is the state of charging, state of functions, and also the state of health. All these things have to be monitored, and also the self-discharge current, resistance, capacity difference. Okay, so because of all these things, they have different performance characteristics. Because each cell, we are connecting different cells, okay, in series to form the pack. So what happens is, each of the cell is having different characteristics. Okay, so each of the cell is having different SOS. So what happens is that they have different performance characteristics. So what happens because of this is, it is having reduced lifetime and as well as the performance. And also, it causes extreme temperatures because of charging and discharging. And because most of the cells are connected in series, not all the cells will have the same sort of charging or discharging or the charge in that. So what happens is, the least charged cell, that is going to determine the end of discharge, even if there is still energy stored in the other cells. Because if one cell is going to get discharged fully, even if the charge is available in the other cells, that particular cell is going to decide the performance of the whole cell pack. Okay, so because of that, it reduces the capacity of the pack itself. And also the charge unbalancing. What happens because of the charge unbalancing is that it increases over time and if it is not properly managed. So we'll have to measure the parameters of each cell, each individual cell and the module from time to time, and it has to be taken care. That is taken care in the battery management system. So battery management system is to acquire the data from the battery from time to time, because as said, it is made up of many cells which are connected in series, and the performance of even each cell is going to affect the performance of the whole pack. Okay, so now what is this BMS is for? BMS is for monitoring and damage protection of the battery cell. Next, safety in operation. The next one is increasing the performance of the cell. Okay. So comparatively, the different parameters are taken for the different batteries. That is, the battery characteristics have been compared for the different batteries. That is, a lead acid battery, nickel cadmium battery, nickel metal hydride battery, lithium ion battery, for which different parameters are compared. There is specific energy, specific power, open circuit voltage, operating temperature, life cycle, and then cost, environmental impact based on these criteria. That is, the battery capacity falling below 80%, or production cost highly dependent on the volume based on eco indicators. Like that, many parameters are taken and the results are taken from each of the battery cells. And the best out of it is being chosen as a lithium ion battery. Okay, so now fixed with the lithium ion battery, we are going to proceed with the thermal management. So why do you go for battery thermal management? Why it is important? First one is to ensure the battery operation under optimal temperature range within the reasonable temperature spread. Why it is going to affect, why the temperature is going to affect the health of the battery if it is above or below the limits that we are going to see. And also monitor the state of the battery and detect the critical point of the battery failure and deliver alarm messages whenever it is above or below the value, that is a nominal value. For example, the voltage, current, or the temperature. Those are taken as the states. And suppress the thermal runaway propagation. Because if a particular cell is having a thermal issue, then it will be propagated to all the cells. And ultimately the whole pack is going to get affected because of this. So now, what if the battery is too cold or too hot? What will happen? Actually, when you are looking at it, so the battery manufacturers have given the specific limits for the temperature of the battery. And as such, we know that for lithium ion battery, the temperature range is given. Okay, so it is given here. In the tabular column, we can see. It ranges between -20 to 55 degrees, for example. So what will happen if it is going beyond that or going below that? So what will happen? So here we know that lithium ion battery is generally set at -20 to 55 degrees for discharging and 0 to 45 degrees for charging. That is the nominal values for the temperature for charging and discharging. So what happens at the usual operating voltages? Okay, so it is normally it is operated at the voltage between 1.5 volts to 4.2 volts. So we know the operating range of the temperature, that is -20 to 55 degrees, and when the temperature goes beyond 120 degrees, so what will happen? Combustible gases will be produced, and after 130 separator would start melting, because I said the cell is made up of anode, cathode, and separators will be there, which are kept inside the enclosure. So what happens if the temperature goes beyond 130, the separator would start melting, and the positive material will start decomposition. And if the temperature goes beyond 200, then what happens is there will be protection of oxygen, and decomposition of the positive electrode will be there and can cause the thermal runaway. Okay, so we have seen what if the temperature is high, because the nominal temperature is between -20 to 55, and for discharging, and 0 to 45 for charging, and the usual voltage is 1.5 to 4.2 volts. But if the temperature is beyond 120, the combustible gases will be formed. Beyond 130, the separator would start melting, and decomposition of positive material will happen. And if it is beyond 200 degrees, then there will be production of oxygen, and decomposition of the positive electron will take place. So what will happen if the temperature is lesser? So if the temperature falls below 0 degrees, then what happens is it will cause metallic lithium deposit on the carbon negative electrode surface. So it reduces the lifetime of the battery. So what happens? The cathode would break down and lead to short circuit. So this happens because of the high temperature and low temperature. So there is a need for managing the temperature. How we are going to manage the temperature for the battery. And also we have to see what will happen because of over discharging or overcharging of the battery. So over discharging the battery will lead to collapse. That is the phase change. It is otherwise called the phase change, which results in the low battery performance. And extremely low voltage or overcharge can reduce the electrolyte. It produces combustible gases and creates safety risk in the battery. That is what is given here. Once again, I am having throat pain. So as we said, what will happen because of over discharge? Over discharge produces combustible gases, and there is a safety risk in the battery. And overcharging can cause positive electrode to decompose and produce considerable heat in the battery. So it produces internal short circuit. So now coming to the battery management system, which I can show in a block diagram here. So the battery management system consists of the following blocks. Okay. So the major block is for the battery state. So what are the battery states to be monitored here are current, voltage, and temperature. So time to time these values have to be accrued using the data acquisition module, and it will be determined. So what's the value? It has to be analyzed, and the interfacing has to be done, and also the safety norms have to be followed here. So what is the range and all they have to check. So based on that, it will take care of the thermal management here. So what are the different BMS here? So different BMS are nothing but it can be categorized as centralized, master slave, modular, and distributed based on the functionality. So what is centralized battery management system? Centralized battery management system is nothing but it is an assembly. There is single controller is connected to the battery cells through number of wires, making it, because it is a single controller, it is so compact, cheap, and easy to maintain. But what is the difficulty with this is it is very bulky, and also it is having a disadvantage. Okay, so it is high in cost. It is a major disadvantage of a single controller, that is a centralized BMS. Centralized battery management system is that it is of high cost. So we are going for another master slave configuration. So master slave configuration, what will happen here? There will be many slaves. That means many measuring devices will be there, which will be taking the parameters and it will be feeding to the master, and the master module will handle the computation and communication. Here the communication is there. So it will handle the communication part here. So the main advantage is here. So in the like a centralized BMS system, what is the disadvantage? The major disadvantage is the high cost, but the cost will be reduced here in the master slave configuration because the slaves are of very slightly lesser cost. So the cost is getting reduced here. So next coming to the data acquisition here. Okay, so now we said for the monitoring of the states. So what are the states we have taken? We have taken current, voltage and the temperature. We are going to acquire the data using the data acquisition module. Here, while acquiring the data, first the voltage has to be taken. So how the voltage is taken is because we know that many cells are connected in series for getting that particular voltage. So it has to be acquired to measure the voltage. And there is accumulated potential. When the cell voltage is measured, it makes it impossible to have unified compensation or elimination methods. Okay, so we'll have to acquire the voltage necessarily. Then the temperature and the current measurements how to be done or monitored in real time, so that it will be checked whether it is within the nominal values, within the optimal values. Okay, so here for measuring the temperature and the current, there will be heat variable resistors. They are placed in the seam of the batteries. And the measuring of the current, it plays a significant role. Okay, so for estimating the SOC, that is the state of charging. And also to measure accurately, generally Hall effect sensor will be used. We know what is a Hall effect sensor. So data acquisition is done and the battery state estimation has to happen. What are the different states we'll have to estimate are nothing but state of charge, state of health and the state of function. So what is the state of charge? State of charge is nothing but that is the indication like in the gasoline cars. Okay, so it is like how much gas is there or how much petrol is there, like that. Here the state of charging will give you an indication how much charge is there. But it is very hard to estimate because of the varying environmental conditions or charging and discharging cycles. Next, state of health. It compares the utilized battery to a new one. So there will be a comparison between these two. And the state of function means performance of the battery in meeting the real demands. And it is determined by both SOC, that is the state of charging, and the state of health. So here, in the state estimation or the state determination, we are going to find the states of charging, state of health, and the state of function. Okay, while doing so, the state of charging estimation can be done by means of discharge test method, Coulomb counting method, open circuit voltage method, artificial neural model method, or fuzzy neural method. Then traditional method like Kalman filter, electrochemical impedance spectroscopy method. So like various techniques are available for that, and also for SOH estimation, SOF estimation, everything can be done. Next, coming to the charge equalization. Actually, we know that many cells will be connected in series to form the battery pack. And also we know that the discharging or very little charge available in one cell is going to affect the other cells also which are having like a required quantity of charging. Okay, that is what we saw. Because the total performance depends upon that particular cell which is having very less charge. Okay, so how we can compensate for this? Because we know that charge is available in other cells, and we don't want that single cell which is having less charge to affect the whole performance of the whole pack. So how we are going to take care. So it can be charged by different methods in EV applications. We know that. And here in charge equalization, that is, it can be like the cells with a higher charge can be made to share the charge with that of the other cells which are having lesser charge. So this is what is charge equalization that can be done. And next coming to the thermal management. So why we want to discuss about the thermal management is that because I said the increase in the temperature or decrease in the temperature is going to affect the cells. Because I said why we have to go for the thermal management, because we don't want whether the like a battery is too hot or too cold, because if it is too cold it cannot be charged fastly, and also if it is below 0 degree it will lose charge, lose power and acceleration, driving everything will be lost. As I said, there will be deposition of lithium. Okay, so this is what is happening in the cold countries like Russia or Canada. Okay, but when it is very hot, like India, so what happens is the battery performance degrades. Mostly the temperature is the temperature within the battery. Okay, than the outside temperature, the temperature within the battery is going to degrade the performance of the battery. And also I said, if the temperature is very high, then what is going to happen? It is going to melt the separator itself. Okay, so there will be decomposition of the terminal cells. So there is a need for the thermal management. That is what we saw here. So thermal management is needed, and so basically this battery management system acquires data and the ambient and the battery temperatures, controls cooling, heating operations, and transmits this information, okay, during undecided operating conditions to take care. So what are the various heat sources of the battery? So here the various heat sources. Why the heat is generated in the battery? Actually we are giving electrical supply. Okay, so but why the heating is occurring? Because we go for faster battery charging. Okay, recharge power, if the recharge power is greater than or equal to 200 kilowatts and we want a faster charging, so the time is less than or equal to 30 minutes, for example, if we take. Okay, so the faster battery charging results in the internal loss of Joule's heating, that is I square R loss will be more. When you are fastly charging, this internal losses because of the Joule's heating effect will be more, because of which enormous amount of heat is being generated which has to be cooled. Okay, and also the temperature variation, because I said because the electrical unbalance which affects the battery pack operational performance. Because I said like if at all one battery cell is at a different charging level, it is going to like affect the whole pack itself. So by thermal management, what is thermal management includes? It includes the temperature effect that is within the cell. Okay, so it includes the life cycle deterioration, that is because of aging. So because of aging and also thermal runaway, because I said continuous usage of the battery, okay, it is going to affect the anode, cathode and as well as the separators. So it is because of the wear and tear of that. And also heat sources and things, so what can be used. Okay, so electrical heating is because of this. And it can be because of the reactions. Either it can be exothermic reaction or endothermic reaction. In exothermic reaction, giving out heat, and endothermic it is going to take heat for the chemical reaction. Okay, so it can be either electric vehicle or hybrid electric vehicle, and the temperature control can be done either by cooling or heating, because we are going to use the vehicle at different countries. Like if suppose it is like Russia, Canada, it will be below 0 degree, or it is country like India, when we are using, it will be, the temperature will be higher. Okay, so depending upon where we are going to use the battery, either it has to be heated or cooled. So how we are going to do that? We are going to see that now. So now we have the battery, and the battery temperature is to be maintained, and how it can be regulated can be by air. Okay, so by air, like the cooling fins can be there. So by circulating air, you can cool the battery. This is the cheapest way of cooling the battery. Or by using a coolant and air also it can be done. Okay, so the coolant also can be pumped using a pump, and then air can also be employed here. But the cheapest technique is by using air only, because it doesn't need anything extra. Like coolant here for air, it doesn't need any pipes for the coolant. So it doesn't need any pipe, and also it will not be heavy because of the piping and all those things. So it will be heavy if you are going for liquid level cooling. And for air cooling, no such accessories are needed here. And here you can either add a coolant and as well as the air for cooling. And when we come to air cooling, another medium also can be used here. And you can use the heat exchangers here. So the outside air will be coming, and if at all it has to be heated, the battery has to be heated. This air can be supplied by a heater, so that this will give the heat to the battery for heating up the battery when the battery is used in the cold places. Or otherwise, a coolant can be used for taking away the heat from the battery. And cheapest means is, and also the easiest means is by using air for cooling. Okay, so next coming to the here we are using like a heat exchanger, the different models of the heat exchanger. So for effective exchange of the heat, that is for cooling them. So next here a refrigerant can be used. So this is a very effective means for cooling, that is by using a refrigerant. So here, a refrigerant material is used. Refrigerant coolant is being used here for direct cooling, and we can see here it is being pumped, and then for liquid cooling, the coolant is being pumped, and which removes the heat, or it can be used using the heat can be removed by using the liquid immersion also, where the battery cell will be immersed in a liquid. So when we come to the air cooling, so here, as we said, it is the simplest and the low cost cooling technique. Why? Means it eliminates the need for the cooling loops that we normally have for like a liquid cooling. In the liquid cooling, what happens is the coolant has to be supplied, which removes the heat from the battery. Then that heat from the coolant has to be removed. Okay, so for that, once again it has to be cooled and then recirculated. So there are many loops which have been used for the coolant, that is the liquid coolant, which is not needed for air cooling. So, and also there is no a problem of liquid leaking into the electronic parts. But in the case of the liquid cooling, there is a problem of liquid leaking into the electronic parts, and also because the liquid cooling incorporates all the piping mechanism, cooling mechanism, so it will be heavy. Okay, so that sort of problem is not there for air cooling because it is very simple and compact. And the major disadvantage is that here, what is the major disadvantage is that the inefficiency compared to the liquid cooling. Why? Because the homogeneity is not there here, and also like electric vehicles, when it is used in a hot climate, obviously the air will also be very hot. Okay, so temperature variation deteriorates the life of the batteries. So you cannot use that where the temperature, outside temperature itself is higher. And also blower noise is also another problem. So like the hot air, because of the hot climatic conditions, and as well as blower noise is also another problem. Air cooling solutions have their roles and values, obviously. Okay, so commercially, for all using this air cooling are Nissan Leaf, Nissan ENV200, Honda Insight, Honda Fit EV, Toyota Prime. So these are the customers who are using this air cooling. And next, coming to the liquid cooling. So we know that the liquid cooling here, the coolant is being circulated through the tubes and the battery will be kept over that. So the coolant will remove the heat from the battery and the coolant is once again cooled externally and it is being recirculated. So here, so these are the various companies which are using this liquid cooling. Okay, so here, what's happening in the liquid cooling is that so liquid cooled via the base plate. So here you can see that the cooling tube is provided for here. This is given for Tesla. Okay, so here cooling tubes are provided and the coolant is being passed through the cooling tube and it is passing through the EV battery pack. So what happens is the coolant will remove the heat from the cells. Okay, so the same thing is shown here. So here you can see the inside, how it is being arranged in the Tesla. And when it is coming to the Chevy bulb, so here what happens is the liquid cooled via a base plate below the cells. Actually here the liquid coolant is passed through the tubes. Okay, so over that the battery is placed so that the battery heat is removed by the coolant. And the coolant will be cooled outside and then it is being circulated. This is what is happening here in Chevy Bolt. And Chevy Bolt, the liquid cooled via base plate below the cells. So here also, you can see that there are 5 individual coolants. Here you can see that five structures which are passing the coolant here. And the plate is in parallel to enhance the heat transfer effectively. Each battery cell is housed in the plastic frame. The frame with the coolant plates are then stacked together longitudinally to make the entire pack here. So next coming to the refrigerant direct cooling, because we said this is more effective than compared to the air cooling and the liquid cooling. Because here the direct cooling offers a cooling rate which is 3 to 4 times higher than that of the liquid glycol. Here the EVs use the refrigerant direct cooling. Okay, so for example, BMW i3. Okay, so this has a system of refrigerant direct cooling. Here, the freeze frame of the refrigeration cooling tubes are installed in the bottom of the aluminum battery tray. So here, these are kept with the refrigerant cooling, and over that the battery cells will be placed on top of the cooling tubes. Next, coming the fluid immersion. So we said in the fluid immersion, the battery will be kept inside the fluid. Okay, so for easy removal of the heat there. So in the fluid immersion, what's happening is when major original equipment manufacturers, okay, in the car market are utilizing air or liquid cooling methods, some suppliers are turning into new methods. Okay, some suppliers are doing this to increase the thermal demand on vehicle batteries. And overall doing that is for example, Zing. Okay, Zing Mobility, they are utilizing this refrigerant direct cooling. So in this intense battery discharge is required and hence serious amount of heat is generated normally. And because immersion is one of the emerging technology for the battery thermal management, it is easily heat exchanging can be done using the fluid immersion. So here immersion cooling involves submerging the battery cells in the liquid coolant. And in doing so, thermal contact, superior thermal contact will be there and the homogeneity of temperature will be achieved here. And also, additionally, the flame redundant nature of the fluid acts as a safety feature, suppressing the thermal runaway events before they propagate between the cells. Because I said, because the thermal issue with one cell will be propagated to the other cells also. So here such problem will not be there when we are going for the fluid immersion technique. And a key consideration is obviously the choice of the coolant fluid used through primary research. Okay. So here one second. So here, as we saw, it is the coolant is the 3M Novec 7200 engineered fluid is used here. And the fluids are dielectric but vary in their properties with the factors like weight, thermal conductivity, environmental consideration, cost. They are very much extremely important here when we are coming to the fluid immersion. So when we talk about the wing mobility, the major disadvantage is that the technique increases the weight of the vehicle because of the fluid and the battery immersed in that, and it increases the weight of the vehicle. And so far we saw the different cooling methods. One is air, liquid, and fluid immersion technique using the coolant also we saw. And one more technique we saw is that refrigerant cooling technique. So we can have like a comparison of all the techniques we have seen. One is air cooling, liquid cooling, and refrigerant cooling we have seen. So in air cooling, because of the small heat capacity and thermal conductivity of the air, even with a high-powered blower, it does not transport the same level of heat as a liquid can do. So it is of lesser efficiency. Air cooling is a lesser efficiency compared to the liquid cooling. And this has led to the problem of electric vehicle in hot climatic places. Okay, so including more temperature variation in battery pack cells. So this increases the temperature of the battery. And air cooling system is simpler. As you know, it is very simpler than the liquid cooling system. It eliminates the need for the cooling loops, added weight from using liquids, pumps, tubes, can be avoided. So air cooling system is much cheaper. Okay, so it is cooling is low, not for heavy duty or extreme performance, and also not to be used in hot climatic conditions. And system complexity is very simple. Cost is low cost. Why it is low cost is it doesn't involve liquids, pumps or tubes. Okay, so cost is lesser, weight is lesser, and also better in sealing and waterproof. And temperature spread are difficult to maintain even temperature. Okay, so control is a limited control only for this. So air cooling eliminates the concerns about liquids leaking into electronics. That is the major advantage of using the air cooling. So it will not leak into the electronic components. So it is the safest technique. Next, coming to the liquid cooling. So liquid cooling, as compared to the air cooling, this will be it gives a good performance. So compared to the air medium, liquid has a high thermal conductivity and a higher heater capacity, which behaves better in the temperature distribution of the battery pack. So liquid circulation cooling usually behaves better in temperature controlling and uniformity. But it is complicated because I said it involves pipes and then the cooling mechanism and also the control mechanism. All those things are needed here. So because of which it is complex here. And also because of the accessories, it is of high cost. And also the weight is heavy because you are employing various pipes and the control mechanisms. It is very heavy. And the leakage concern is there. And but it is easy to maintain because the coolant, when it is circulated over the battery, it removes the heat from the battery, and the heat from the coolant can be removed by external cooling mechanism. So it is easy to maintain and it is easy to control. So battery thermal management with a liquid circulation loop also has some inconvenience. What is the inconvenience? Is that complexity structure and also the accessories, that is heat exchanger, pump, etc. So it is going to make the complications in this. And next, coming to the refrigerator cooling. So in the refrigerator cooling, we said it has some more efficiency when it comes to removing the heat. So refrigerant direct cooling with fluxes with evaporative latent heat, better thermal homogenization for uniform temperature distribution. It has compact structure because it doesn't involve too many components here, and can be a better choice than conventional battery thermal management comparatively. That is, compared to air cooling and liquid cooling, refrigerant cooling can be preferred. It can be excellent strategy for high necessity of battery thermal safety because there is no leakage, there is no extra weight. Okay, structure is compact, potentially lower cost also, safety advantage and better temperature uniform distribution there. And it can provide emergency cooling because of spraying, okay, and also preventing overheating or thermal runaway propagation. Refrigerator-based direct cooling provides better battery thermal management. So comparatively, compared to all the three techniques, refrigerant cooling gives a very good battery thermal management. So refrigerant direct cooling allows high charging power, reduced complexity, potentially reducing cost, and has had a safety advantage. So these are the different techniques we have seen for the battery thermal management. So I can conclude with this. So we started with what is the electric vehicle, what is the advantage of electric vehicle, how it is reducing the pollution, noise pollution, air pollution, how it is increasing the air quality, and also reducing the noise, and also the various components of the electric vehicle like electric drive, battery. So all these things we have seen, and what are the different types of batteries we have seen. We have seen the comparison of the characteristics of the different batteries, and we have seen how the battery is playing a major role in determining the cost of the electric vehicle, because we saw that the battery is going to contribute 1/3 of the price of the electric vehicle. So battery management is very much needed. Okay, so battery management in terms of electric and thermal management we have seen. So what are the electric management we have seen is current and the voltage, and thermal is temperature. And how it has to be done, we have to do the data acquisition from time to time. That is, various values have to be acquired by different sensors, and they have to be compared with the nominal values. And we have seen what if the temperature is above the nominal value or below the nominal value. Normally we are using the lithium ion batteries. Okay, so what is the range of operation of the battery? We have seen what if the heating occurs above the certain limit or below the 0 degree. We have seen. So how to overcome these temperature variations, and how to cool the battery or heat the battery, we have seen using the heat exchanger. So if it is in the hot countries, we have to go for the cooling, and if it is in the cold countries, we have to go for the heating of the battery. That is by using a heater, that hot air, by using the heat exchanger, it has to be passed over the battery, and in the hot places. So the heat has to be removed from the battery. How it can be removed? First one by air, another by liquid, or by refrigerant. So we have compared all the performances of all the three cooling techniques, and we have arrived at a conclusion that the refrigerant cooling is better, okay, comparatively. So with this, I'll end the session, and thank you organizers for giving me such opportunity. And yes, sir. I was expecting you, Chandrasekhar sir. Good evening.
Yes, madam. Thank you. Yes, madam. Thank you very much for joining us, and the related to thermal management and electric vehicle. I saw the presentation, and we are happy to have such presentation from Madam Professor Dr. Kamala from Jain University from Bangalore.
Thank you, sir. Thank you so much. I am highly privileged, sir.
Yes, ma'am. Thank you. And yes, Kartik Kumar sir. Yes, please.
Madam, thank you for your wonderful session of battery thermal management. The participants may useful regarding your valuable session. Thanks for sparing the valuable time with us. And thank you so much, ma'am. Thank you so much. Is there any doubt from the participant side? Is there any doubt regarding the session from the participant side?
Ma'am, I have one question.
Yes, sir.
Say, as per the lithium batteries, when we are talking, if it is a cold countries, we need to heat it. And whereas in the other side, it is we have to cool it. But in Indian scenario, how best it will work? Because even in India, during the different seasons, different places, even if you look at Gujarat or the north side, it has extreme cold and extreme high temperatures. So in that case, what will be the efficiency or performance of the lithium-ion batteries used in the vehicles?
Yes, sir. I'll let you know, sir, because I've not done that much research in it. So I'll let you know, sir. Thank you, sir.
Thank you.
Thank you, sir.
Is there any doubt, sir? Any other doubt?
Sir, I always welcome the questions. They can send through mail, sir. Please. My mail ID is there with you. You can please collect the questions and send them, sir. Chandrasekhar, sir.
Yes, madam.
Okay.
Any
Yes,
other?
sir. I can address the questions, sir. Thank you so much, sir. Thank you.
Yes, madam. Yes, madam.
Today
Thank
we
you.
have a group photo session. Dear participants, sir, dear participants, please turn on your camera for your photo session. Please, all of the participants, please turn on your cameras. Right, sir. Some of you okay, thank you so much. Thank you so much for your.
Thank you, sir. Thank you, ma'am.
Thank you, organizers. Nice.
Yes. Thank you. I am going to tell the vote of thanks. So I sincerely good evening to one and all. Good evening to one and all for attending this special session. So I deemed it a great honor and privilege to propose the vote of thanks on this memorable occasion. First and foremost, I thank our Chairman, Chancellor, Colonel Professor Dr. Rangarajan sir, and Vice Chairman ma'am, Dr. Sakuntala Rangarajan ma'am, for giving permission to conduct this program. Also, I would like to thank our Managing Trustee, Mrs. Mahalakshmi Kishore Kumar Rangarajan, and also I extend my thanks to IET team who financially support us for conducting this event. We are grateful to the resource persons who are available with us, and my heartfelt thanks to our Vice Chancellor sir, Dr. Salivaganan, and Register sir, Dr. Kannan, and Dean Academic sir, Dr. A.T. Ravichandran sir, and I thank to the distinguished Professor Dr. V. Jayasankar sir, Dean SOEC, and I grateful to our HOD sir, Dr. P. Chandrasekhar, who supported immensely to grand success of this event. And I thank our professor team, Dr. Ramesh sir, Dr. Karnanidhi sir, and our coordinator team, Mr. Satyanathan, Mr. Karpaya, and Mr. Sridhar, and Mrs. Manimegli ma'am, for given special support and backbone to this event to get succeeded. I thank all the faculty members and non-teaching faculty members of this institution. Last but not least, I thank all the participants who are registered for this event to get the program a grand success. Finally, I leave you this inspiring quote by Martin Luther King: "An individual has not starting living until he rises above the confines of his individual concern to the broader concerns of all the humanity." Once again, thank you so much. So now the session feedback will be shared with you. Feedback will be shared with you.
Hello, Dr. Sati.
Sam?
Yes. I hope I am audible to all of you.
Yes, sir. Yes, sir. Yes, sir.
And it is my duty to thank all the resource persons of various sessions, starting from Dr. Albert Alexander from Congo Engineering College yesterday morning, and the afternoon session from it was scheduled with Dr. Sanjeev Badma from Aarhus University, Denmark, and due to unfortunate thing, he could not able to join us in time. And I extend our sincere thanks to Dr. Gandhiraj from Anna University, Bit Campus, Trichy. And today we had Dr. Gurupa from BVRIT, Telangana, and Dr. Selvajodi Madam from IIIT TDM, Kanjipuram, Chennai. And now recently the session was handled by Madam Professor Dr. Kamala from Jain University, Bangalore. And we are very grateful and thankful to all the 6 resource persons in joining us in this esteemed IET sponsored webinar on electric vehicle battery management system. And our heartfelt thanks to all the registered participants across the nation, including WellTech participants also. And we are grateful to have the IET Chennai local network for sponsoring this kind of event. And we are very delighted to have IET participants in joining this particular event. And on behalf of the WellTech University, and on behalf of School of Electrical and Communication, and on my own behalf, and I sincerely thank all the participants, resource persons, and the organizer, coordinator of this program, Dr. K. Karthik Kumar, and the anchor, Madam Manimegli, and Dr. Satyanathan, and Dr. Ramesh, and Dr. Karnanidhi, and the team of faculty and learned professors who supported Dr. Karthik Kumar in organizing this sponsored event, which has come to a very great success. Thank you, and all, thank you.
Thank you, sir.
Thank you. Let's have now national anthem. Is there any doubt? Is there anything to tell other participants and other dear participants? Are you willing to share any feedback regarding this program?
Yes, sir. The session is very informative, sir. Like from we can share our views, we can learn more knowledge about different professors of different engineering institutes. They are doing research in different domains. So it's very informative. The 2-day workshop is very informative. We have more knowledge on the electric vehicle design and battery management systems.
Yes, yes, it is good to hear from Manohar, BSB Manohar. Yes, great Manohar. Yes. Any other feedback? Any participant would like to join us in online feedback? Your experience of this session and this seminar. Okay, Karthi sir, you proceed.
Thank you, one and all. So let us have a national anthem now, and by this we will conclude our IET sponsored 2 days workshop on battery electric vehicle battery management system. So thank you once again. So let us have the national anthem now. Thank you, one and all. Bye, take care.
Thank you, sir.
Please share the complete link, sir. Feedback link.
Yes, sir. I will share the video, which is possible, and I will collect the presentation PPT from the resource person, and we will send mail to each and every participant, sir, individually.
Okay, sir. I had to move to another program, so I will log out. Please share the complete link to our email IDs, our mobile phone.
Yes, sir. So the file size is more for the video presentation. So the PPTs sharing is possible to us for this time. And for larger file, we will share the larger file of our recording, sir. Thank you. Yes, sir. Thank you, sir. Thank you.
பிரகாஷ் வா, என்னடா பண்றது படா பிரகாஷ், எரிச்சலா வீட்டுல
Excuse me, sir. The feedback link is not working, sir. Is it possible to send it again?
Sir, we will share the extended link. Wait.
Yes, sir.
I have shared the link. Please use of it.